Hello everyone, welcome on our YouTube channel Physics Made Easy Kota. In this video we are going to discuss about the ray optics. Here are the few contents which we are going to understand in this video lecture. Our topic for today video lecture is optics. It is a branch of physics that deal with the study of nature, production and the propagation of the light. It has the two sub branches. One is a ray optics, another one is a wave optics. So what is a ray optics? Ray optics is also known as the geometrical optics. It main concern to discuss about the particle nature of the light, and it is based on the rectilinear propagation of light and the laws of reflection and the refraction of light, whereas wave optics known as a physical optics, it concern itself with the wave nature of light, and we learn about the different phenomena like interference of light, diffraction of light and polarization of light in case of the wave optics. What is reflection of light? Reflection of light is a phenomena of light in which light falls on a plane reflecting surface and bouncing back in the same direction. There are the certain laws that hold for the reflection of light. The first law, the incident ray, the reflected ray and the normal at the point of incidence all lie in the same plane. Also, the angle of incidence is equal to the angle of reflection. The reflection of light hold goods for the plane mirrors. Plane mirrors are present in everybody home, and the images are formed in a plane mirror and have some following characteristics. The number one property or a characteristic is the image formed via plane mirror is always virtual, and it is always erect, laterally inverted, or you can say that laterally reversed. The size of the image is always equal to the size of the object. The image is as far behind the mirror as the object is in front of it. The line joining the object and the image is normal to the plane mirror. When the plane mirror is rotated through a certain angle, the reflected ray turned through twice this angle. After plane mirror, there are some another mirrors which are known as a spherical mirror. Spherical mirrors are a part of a hollow sphere. It is a mirror whose reflecting surface form part of a hollow sphere, and the spherical mirrors are of two types. The first one is a concave mirror, the second one is a convex mirror. Concave mirror is that in which the reflection of light take place from the inner hollow surface, whereas convex mirror is that in which the reflection of light take place from the outer blurred surface as shown in the given diagrams. Also, there are the few points that are linked with all these mirrors. The first one is a principal axis, pole, center of curvature, radius of curvature, focus, and we are going to understand about all these points in our next slide. Here are few terms in connection with a spherical mirror. Try to look at all these terms in a given diagram. Pole, center of curvature, radius of curvature, principal axis, linear aperture, angular aperture, principal focus, focal length, focal plane. First, try to look out for the pole, center of curvature and radius of curvature. Yes, pole is a middle point of the spherical mirror. Center of curvature. It is a center of the sphere of which the mirror forms a part, and the sphere is shown completely with the help of the dotted line. Next one is a radius of curvature. It is a radius of the sphere of which the mirror forms a part. Next, we are going to look out from the principal axis, linear aperture, angular aperture. Principal axis, if you observe carefully, it is a line passing through the pole and the center of a curvature of the mirror. Linear aperture, shown by the point AB. It is the diameter of the circular boundary of a spherical mirror. Angular aperture. Look at a point C. There is an angle created at a point C that is known as the angular aperture. Angular aperture is actually the angle subtended by the boundary of a spherical mirror at the center of curvature. The next one is a principal focus. Principal focus is observed when a narrow beam of light parallel to principal axis either actually converges to or appear to diverge from a point capital F on the principal axis after reflection from the spherical mirror. This point capital F is known as the principal focus of the mirror. A concave mirror has a real focus while a convex mirror has a virtual focus. The next one is a focal length. It is a distance between the pole and the focus. Focal plane, the vertical plane passing through the principal focus and perpendicular to the principal axis is called a focal plane. Now here are some Cartesian sign conventions or rules for the spherical mirrors or the ray diagrams. All ray diagrams are drawn with the incident light traveling from left to right. Second says that all distance are measured from the pole, that is the center of the mirror. All distances measured in the direction of the incident light are taken as positive, whereas all distances measured in the opposite direction of the incident light are taken as negative. Height measured upward and perpendicular to the principal axis are taken as positive, whereas height measured downward and perpendicular to principal axis are taken as negative. These rules are applicable for both spherical mirrors. Focal length and the radius of curvature has a relation between them. Focal length is always is equal to half of the radius of curvature. And one thing to remember that focal length and radius of curvature are taken negative for concave mirror and positive for convex mirror. 1 upon u plus 1 by v is equal to 1 by f. This formula is known as a mirror formula or a spherical mirror formula. This formula gives relation between the object distance, that is denoted by the u, image distance v, and the focal length small f of a spherical mirror. Magnification, linear or transfer magnification. Magnification deals with how the image appears to the observer, whether it is magnified, diminished, and of the same size. Mathematically, it is defined as a ratio of the height of the image to that of the object. H2 taken as the height of the image, H1 taken as the height of the object. This formula further equal to the minus V upon U in the terms of the object and the image distance from the mirror. If magnification is greater than 1, or we can say that the magnitude of the magnification is greater than 1, then the image is magnified. If it is lesser than 1, then the image is diminished. If the magnitude of the magnification is equal to 1, the image is of the same size as that the object, that is, this is the case for the plane mirror. If magnification is taken positive, the image is virtual and erect. If magnification is negative, just remember then the image is real and inverted. These things are helpful to solve the numericals in which the formulas of the magnifications are involved and to predict about the nature of the image formed from the formula of the magnification. This glass is transparent, and when we add water, we observe that the pencil show a little bit bend in its position. So how this is happening? So the question comes in our mind, how the pencil get bends. The pencil get bends because of the refraction of light, which states that when light goes from one medium to the another medium, like in this case from the air to the water, there is a change in the velocity of the light, and that's why the light show the bending nature of the pencil. And this is just only the difference in the velocity of light for one medium to the another medium. There are the certain rules that must get followed for the laws of reflection of light. The first law says that the incident ray, reflected ray, normal at the point of incidence all lie in the same plane. The second law is also known as a Snell's law. It is a ratio of the sine of the angle of incidence and the sine of the angle of reflection, and which is constant for a given pair of medium. And this constant is known as a refractive index of one medium with respect to the another medium. The concept of the refraction of light has a various applications. The first one is the critical angle and the total internal reflection. Firstly, we must know what is a critical angle. Critical angle is the angle of incidence in the denser medium, for which the angle of refraction in the rarer medium is 90 degree. It is denoted by I with the subscript C. So when we say that angle of incidence I is equal to IC, then R, that is the angle of refraction, is equal to 90 degree. This is shown in the given diagram, that when the light incident in case of a denser medium at I is equal to IC, then R is equal to 90 degree. And also by using the Snell's law, we come to the relation that mu, that is a refractive index, varies inversely with the critical angle. And when R is equal to 90 degree, the light falls on the boundary between the two mediums. Using this knowledge, we understand easily more about the total internal reflection. Total internal reflection is actually the phenomena in which a ray of light traveling at an angle of incidence greater than the critical angle from a denser medium to a rarer medium is totally reflected back into the denser medium, and also it obeys the laws of the reflection. This is clearly shown in the given diagram, that when there is an increase in the angle of incidence from the critical angle, the total internal reflection take place. But there are the few conditions that must be fulfilled for the total internal reflection. The first, light must travel from the optically denser medium to the optically rarer medium, and the angle of incidence, as discussed earlier, in the denser medium must be greater than the critical angle for the two media. Now the use of the total internal reflection and how this phenomena is applicable in our day-to-day life. The best example is the optical fibers. Optical fibers are widely used in the telecommunication. Optical fibers consist of thousands of fine strands of quality glass coated with a material of lower refractive index. Light entering the fiber at one end undergoes several total internal reflections, and it finally emerges out without any change in the intensity of light. A bundle of optical fibers is called a light pipe. This is used in telecommunication for receiving and transmitting signals, also used in medical and optical examination. Now we are going to learn about lenses. Lenses are different from mirrors. A lens is a piece of a refractive medium bounded by two surfaces, at least one of which is a curved surface. Lenses are of two types. One is known as a convex or a converging lens. The second one is known as a concave or a diverging lens. They have the different appearance. The convex of the or converging lens is the thicker at the center than at the edges. It converges a parallel beam of light on refraction through it. It has a real focus, whereas a concave lens is differ in look from the convex lens, as it is thinner at a center than at the edges. It diverges a parallel beam of light on refraction through it. It has a virtual focus. Center of curvature. Lens has a two center of curvature. It also has a radius of curvature. Principal axis, again the line passing through the two center of curvatures of the lenses. Principal focus, a narrow beam of light parallel to the principal axis either converges or diverges from a point on a principal axis after refraction through a lens, and that point is known as a principal focus. Again, it is easily to remember that a principal focus are two in case of the lenses. Optical center, it is the point situated within the lens through which a ray of light passes undeviated. Focal length, it is distance between the principal focus and the optical center of the lens. Aperture, it is a distance of the circular boundary of the lens.